So this is, I think, I, or 3I, on problem set number 8. For this problem, I notice that everything is divisible by 2. So I'm going to probably divide off by 2 to make the problem a little bit smaller to work with. And then start looking at some properties here that we can maybe do some renaming of. In other words, I see 2 sine theta cosine theta is sine 2 theta. And I'm going to subtract, set this equal to 0, see if I have any hope of factoring or doing anything with this. If I subtract sine squared from both sides, the cosine squared is going to still be here. This is cosine squared theta minus sine squared theta. Okay, that's not the Pythagorean identity, but that is the double angle formula for cosine. So that's cosine 2 theta plus sine 2 theta equals 0. All right, at first it doesn't look like we're really going anywhere with this, but I'm going to move the cosine 2 theta to the other side. So it's going to be negative cosine 2 theta over there. And one of the things that I noticed too is they both have the double angle. So if I divide both sides by cosine 2 theta, I'm going to end up with a negative 1 on this side equals tangent 2 theta over here. Okay, this problem is supposed to be solved on the interval from 0 to 2 pi. That's for theta. If I'm interested in 2 theta, I need to double this. So I'm going to double or times each of these by 2. 0 times 2 is still 0. This is 2 theta. And now I go around to 4 pi. All right, so let's just think about first, where does tangent theta equal negative 1? All right, so on my little circle wheel, I know at pi over 4, that's where it's equal to positive 1. So over here at 3 pi over 4, right, I'm at negative 1. And then also down here in quadrant 4, so that would be 7 pi over 4. All right, but that's what 2 theta is equal to. 3 pi over 4, 7 pi over 4. But we're allowed to go around 2 loops. And I've only gone around once, so adding another loop to this, or another 2 pi to this, if I add 3 pi over 4 plus a 2 pi loop and get a common denominator, that's 3 pi over 4 plus 8 pi over 4. So that's another 11 pi over 4. That's another possible solution. And then swinging it around again one more time to 7 pi over 4. If I take 7 pi over 4 and add a 2 pi loop again, because I get to go around to 4 pi now because this is double angle, this is going to take me to 15 pi over 4. But that's for 2 theta. I'm just interested in solving for theta, which means I need to divide each of those angles by 2. So instead of 3 pi over 4, I'm either going to divide by 2 or multiply by a half, and it's really 3 pi over 8. And then, again, do that for each of the angles, and those are your, it should be 7 pi over 8, 11 pi over 8, and then 15 pi over 8. Those are your 4 angles that would satisfy that original problem. But the key, I think, is seeing right here the cosine 2 theta plus sine 2 theta, that if you divide off, you're going to get tangent 2 theta. And then knowing, kind of like when we do the half angle where you have to divide everything by 2 to see what quadrant you're in, this one you needed to multiply the angle by 2 for the double angle, which meant you get to go around the loop twice, not just one time, for your solutions.